Hey everyone, I'm working on homework 2. So let me share that up and show you what I've got so far. Um, I did the first few graphs. Actually, I want to kick this off with an apology. I did not realize how confusing the assignment was to read. Yeah, so here's the assignment, right? 1 through 4, these guys, and then 10 and 11 are in the book. They're in chapter 2 of the book. And then in addition, I also wanted you to make extra graphs. And so you have to do 10 and 11 before you do 1 through 4. And then you have to, once you've made the graphs, or once you've done 10 and 11, make the extra graphs, including the clustered bar chart, which I'm going to go over in just a second. So what I've done so far is I've got it all typed in here. So let me, sorry, it's a bit of a mess. Just copying this over. I've got this all the data typed in here, and I'm going to go ahead and I'm going to go ahead and show you how to make these graphs. It's real simple, but I figured it might be helpful. I'm going to go ahead and add a sheet here. Let's call this one like how's that? That sounds pretty good. Can I just stick these on a new sheet? Hello? Drag? Will you go there? Absolutely not. That didn't work at all. Okay. I'm gonna. Hello. We're having some problems grabbing things. Sorry. All right, so I'll just leave them in a giant mess here. I do want to show you. Don't leave here. don't turn this in. Right. Copy paste these over to something nice. Make it look good. Right. So I've copied the first ones over. I did the science competition populations. I'm going to do the overall student populations now, and of course we're making a bar chart, pie chart, and line graph. And I have to say, line graph is probably not super appropriate for this data. Line graphs are really for trends, and this isn't one of those. This and the bar graph are really pretty much exactly the same thing. But I wanted you to figure out how to make a line graph, basically, so I assigned it. But I think in the future I'm going to change that to something else. Anyway, so I want to do the overall student population. So we're going to select high school and this guy. So oh, by the way, should I select more than one thing? If I just click, does it work? No. So if you click on a column, it selects the column, right? And I'm going to hold Control and click on this other column, and it'll select more stuff without removing the other click, which is really nice. You can also do that with Shift, by the way, although Shift grabs everything between. So if I hold Shift while I click, notice that it grabs everything up to that point. If I hold Control, so here I just click, and then here I hold Control while I click, and it grabs those two. So really helpful. I'm going to go ahead and make a chart. This one looks pretty good. I don't like the verses. I like the word by here. Overall population by high school. There we go. Looks pretty good. I think I want data labels on here. I think that would look nice. I put them on the other one too. So we're going to go ahead and go to series, I believe. Overall student population. Let's make that red to contrast with the other one that was blue. And we're going to put data labels on there. And I think that looks okay. I don't feel any particular need to go tinkering around with it, but we can customize this in a bunch of other ways. But I think I'm good with the pie chart there, or excuse me, with the bar graph there. Close that. Just gonna pile this on the other ones. I know that's super messy, but I'm doing it anyway. Oh, I clicked off the whatever. Okay, so Control click, make a chart. This will be a pie chart. Column chart. We're gonna pie chart here. Overall student population. Doesn't say by high school. That's weird. I didn't do that. This looks fine to me. I believe those are the same colors that were on the other one, which is nice. I like keeping my graphs parallel with each other. Yeah, I think we're good. I don't feel any need to do anything else there. And we will make another chart. Chart. This guy's gonna be a line graph. Line population. See, this one said high school. Why didn't the other one? That's so weird. I didn't even change anything about that. I'm going to go ahead and make the line red here to go with the red bars on the other one. Series. color red. And I'm going to put data labels on too. Now, on the other one, it wouldn't show the top one. Yeah, see, this one got, like, the data label on this highest point here got cut off. So what I'm going to do is I'm going to make the maximum 35. I know it's in here somewhere. Oh, no, sorry, it's the vertical axis, pardon me. Close this one. Let's go look at the vertical axis. I'm going to make the maximum value 30 or 0.35 because this is in percentages. And so if I put in 35, you can see what happens. It goes up to 3,500%, which is what 35 is. So that's what excuse me. Hello, 0.35. There we go. Great. So I don't know why it goes up to 40 now, but whatever, that's fine. So that looks pretty good to me. Yeah. Okay. So what I'm going to do now is I'm going to paste these into in my doc, or my Google Doc. Normally I would just do that off camera, but I think it might be helpful to do it on camera here to show you some of the tricks I'm using to do to make it look nice. And I guess I don't want these all in the same pile here. Let's overall population. Okay. So what I'm doing, there's a couple ways you can do this, but I'm just gonna just copy paste. So I just hit Control C. I'm gonna go over here, and then I'm going to paste it in. Now it's gonna look like a mess at first, right? So let's go down here. So paste. So I'm pasting this unlinked so that in case the spreadsheet gets deleted or moved or something like that, it won't ruin the graphs. I just want, this is essentially just a picture. It's not linking to the spreadsheet itself. All right, so when I say it looks like a mess, I mean, it looks fine, but it doesn't look like these. So let me show you a couple things. One, I want to make them all the same size, right? I want, like, I've made these line up very nicely. I'm going to put them in the same order, everything else. So when you go look at this, image options, when I click on this, I'm going to click on image options, go to size and rotation, and it's telling me, so this is 2.98 inches wide. And log aspect ratio means it's going to keep the ratio of the width to the height the same if I change one of them, which I'm going to. And to make it look nice, I'm going to change it to, I'm going to change my new picture to be 2.98 inches wide, and it'll automatically change to 1.83 inches high, hopefully. All right, so we're going to go here. Yeah, so we're going to change this to 2.98. And notice that it's got the height right, which is great. So it's the right size then. So I'm done here. And then I want this. So these are the various text wrapping options. So this one looks really nice if you're trying to highlight something. This is the one you want if you want to be able to move it around within text and have the text wrap around it. And then this is terrible. Mostly don't use this. This treats this thing like one gigantic letter. And so it makes your line huge, and it looks right almost never. So I'm generally choosing between one of these two. I'm picking this guy because I want to be able to move it around. So I'm going to take this and I'm going to grab it, move it up here. And so a couple tips for you. I'm going to move this up here. See that red line? That's snapping to the other picture. So it's lining up the center of this picture with the other picture, which is great. I'm just going to leave it there because that's where I want it to be. I want it to be lined up so it looks nice. Yeah, and so I'm going to go paste the pie chart in, and we'll use the same technique to line it up under here, or line that picture under here. Where was the pie chart? It's this one. Oh, not that one. Go back, please. This one, that one. All right, so I'm going to copy this, and we'll go back to here, paste it in, unlinked. Terrible. Go ahead and change this to 2.98 inches wide. You could also change it to 1.83. Oh, wait, 2.98. On this one's 1.85. It's so strange, the variation that you get. I don't know why this one's a different height. It was literally all made in the same program. All right, so we're going to grab this. We're going to make this not inline, but have the text wrap around. So notice that it gives me the red line to snap to there and to snap to there. And it's all pretty. Look at that. It's so nice. All right, and I'm going to go grab the last one. This guy. We're going to control copy, go back here, paste, do the same thing, unlinked, change the size to 2.98 inches wide, so it is all the same size. Grab this. Oop, hello. Oh, right. Sorry, I forgot to change it to text wrapping. Until you change it to text wrapping, it won't let you drag it around because it's treating it like a letter, and you can't just drag text around like that. That red line on the side, by the way, was the edge of the printable page. I don't care if this is printable, so I'm happy to go over it. All right, so I've got my graphs. If I wanted to get extra fancy, I could put borders on them and all kinds of stuff, right? Like I could go down here. Let's see here. If I go to all image options, it's these guys. Do we have some borders? Yeah. So there's a size, text wrapping. Lets you wrap. This is the one I'm using, the one that lets you kind of drag around. This one will put the text above and below, but won't put anything on the same line, which is fine. You can also wrap only on one side if you want. Well, just experiment with that. This will tell you how far away from the text it will, like when you're moving around, it doesn't put it like right on top of the text or right next to the text. This is the buffer, or the, what do they call this, a gutter? Or they're calling it a margin. That's fine. I think that's a better name. Yeah. And then you can move the position manually, or you can move the position, like this will tell you, like, let's say I wanted to be very, very fine in my movements. I can change the numbers instead of 3.58 on the X, which is how far right it is. How far right it is from the left margin. I could make this like 3.6 if I wanted to be really precise. I don't. Where are the borders? There should be some borders around here somewhere. I'm sure there's a way to wrap borders around it. I don't know where they are. Oh, here we go, border. Yeah, so we could, I currently have it set on no border. We could make it a black border. And there we go, the border. I think that looks worse. I'm going to get rid of that. I like no border there. Yeah, I don't know, maybe I like borders. I think I might like borders on those. I'll decide later when I'm posting this. Yeah, so there we go. So that is number 10 and 11. So 10, comma 11, I guess is what I want to say. 10, comma 11. Sure. All right, and then I want to do, so 10 and 11 come first, and then 1 through 4, of course, just like you would normally. Oh, also, let me show you how to do a clustered bar chart. It's really easy. There is not much to it. Okay, so I am going to delete all of these, I think. I don't have any need to keep them. I guess I could, so one thing that you can do is you can move it to its own sheet if you want. I guess I want to do this one first. Yeah, I'm going to put them all in their own sheets. And it will, it'll just make new ones. They just call it chart 1, right? So I'm going to go ahead and do that so that they are all out of the way. It's a little slow, sorry. Move to own sheet, because I don't really want to lose these. And I'm going to use this for future homeworks as well, or for future classes. I'm going to use this homework for future classes, so might as well keep it around. So that I don't have to remake the charts. Not that it took particularly long. All right. So now what I want to do is I want to make a clustered bar chart. So what it's going to do is, well, firstly, I'm going to grab all the data, right? So I want this all the way through C, and I'm going to make a bar chart. And I think it actually defaults to clustered bar chart. Yeah, it does. So notice that what it has done, it has grouped up by school the science competition population and the overall student population, which is great. Oh, it even made them blue and red. Oh, that's a nice touch. I didn't even intend that. Yeah, and so I'm going to say, the overall student population by high school. There we go. Yeah, and so this gives us a nice way to compare the two, right? So you can see that Alabaster has a very high science competition population and a low overall student population, which means they are a small school that is probably very focused on science, or at least they have a big science club or something. And West End is just the opposite. They're a big school with a low science competition population. Now, if you want, you can also cluster by, you can also do, what am I trying to say here? Cluster by science by populations. So if I go to, where is it? Where plans and ticks, which one is the, there's a switch, switch axes in somewhere, switch axes somewhere in here. Not here, but it'll allow you to cluster by the other thing, basically. Let's see if I can find it here. Legend. It's not going to be a legend. No. Oh, there it is. Probably. Yeah, reverse axis order. There we go. Whoop. No, that's not it. The heck? Done this before. I don't know where it is. Yeah, apparently I don't know where it is. There's a way. There's an option in here somewhere. I'm not gonna waste any more of your time poking around for it. That will let you choose. Let you choose to do it by the other two things. I think it's called flip axes or reverse axes or something like that. But anyway, that's all I wanted to do on this. I'm perfectly happy with this. Although I guess I am going to add data labels, right? I think those would be probably better if I did. Yeah, that looks better. So you can see what the numbers are and compare them more directly if you want to. But I think I'm good with that. I'm just going to copy paste this in. I'll go ahead and copy this and go ahead and go back to homework 2. Paste it in. Yeah, maybe it fits there. We'll see. Unlinked like the other ones. I think I might make this one a little bit bigger than the other guys. See if maybe we make it like 4 inches wide. See if that fits on the previous page. It doesn't. Make it 3 inches wide. Does that not fit? Yeah, it does. Okay, great. I'm just going to take this and drag it into the middle now. That's nice. They have a middle guide as well, in addition to the guides that go with the other graphs. They'll snap to the middle of the page if you let it, which I do want it to do that. And then I'm gonna answer 1 through 4 here, which is what the rest of the video is going to be. So let's cancel that. Nope, that's not the right thing. I meant this one. There we go. All right, so let's see what the question asked. All right, the cluster bar chart you made, how could you interpret the relative sizes of the bars in each cluster? For instance, one of the bars for Alabaster is much higher than the other, but for Concordia, the relative bar sizes switch. What does this mean about those schools? And it means the thing I said a second ago, which is Alabaster has a high science competition population and a relatively, and a small overall population. I interpret this to mean that Alabaster is a small school with a heavy focus on science. Opposite true for Concordia and West End. They're large schools with low science competition population. So they have much schools with science competition population. I was a parent in this county, I would probably want my child to attend Alabaster or Tennyson rather than the other schools. Something like that. Oops, that's not what I meant to do. Number 2. If you're comparing 2 different sets of data, for instance, number 10 and 11 in the section, what are some things you can do with a chart or graph to make the data more comparable? All right, so we want a few things. I want to list a few things. So how do I want to do this? We can so the number one thing, make the scales on the graphs the same. Graphs on different scales are hard to compare because what your brain wants to do is see something and think that if it looks like something else, then it's directly comparable to something else, and it's not going to necessarily take in the axes at first. So for instance, it's really good here that these both go up to 40%, right? And that everything's in percentages, and this goes 30% and 30%. If it didn't, we should have changed them to be that way, right? So that they're easier to compare. So scales on the graphs the same. Make sure the graphs are comparing things that are actually comparable. For instance, don't put percentages and so what I'm trying to say, don't put percentages and counts on the same graph. I will show you a funny graph in is it chapter 3? No, it's got to be chapter 2. Yeah, I think it's like number 16, chapter 2. Maybe we can just pop over there for 1 second, and you can see the thing that I consider the worst professionally made graph that I've ever seen. It is ridiculous. I think it's like number 60 something here. It's the Rob Ford graph in this chapter, I believe. I think it's right here. No, somewhere around here. Oh, it's somewhere in this chapter. I asked about it on one of the homeworks. It's nonsense. They put way too many things on the same graph. Yeah, it's actually an extra credit question to improve the graph on a future homework. So I'll just leave it at that. When you see a graph that looks like one has percentages and counts on it at the same time, and 2 is about Rob Ford, the former mayor of Toronto, see if you can fix it and see if you can understand it, because it's not great. Anyway, don't put percentages and counts on the same graph or on comparison graphs. Yeah, that's what I mean. So, and we did. These all look nice. And we're what else do I want to say? I forgot exactly what the question said. If you're comparing 2 different sets of data, what are some things you can do with the chart or graph to make the data more comparable? Readable. Right. So if I'm comparing one graph to another, I want it to be obvious which things I'm comparing. I feel like that's enough. You could probably come up with some more things. I'll leave it to you, but make sure your scales are the same on both axes, both x and y. Although in this case, the data is, or the high schools are qualitative, obviously, so it's not a histogram; it's a bar chart. But make sure it's the same high schools on both. Make sure that you're comparing like things. We're comparing percentages to percentages. Yeah, etc. Oh, I guess I also want to say this. Put the graphs near each other in a way that makes them obviously comparable. So for instance, what I mean by that is the bar charts. These bar charts, they're on the same axes, they're right next to each other. So the things that you're comparing, which are the heights of the bars, are in one continuous line. It's actually better to do it this way than it is to take this and put it down here, right? I wouldn't want to take this guy and put it over here, although I could, right? Because now it's not as obvious with like how the bar heights compare. I mean, it's relatively obvious in this case because they're pretty big. But if they were a little bit closer in height, it would be less easy to see because you're trying to compare heights up and down, which isn't natural. What you want to do is use this, right? So I'm going to compare this height to that height and this height to this height, right? And you can just look at the graph and see how they look. Now, of course, we put that all in one chart to make that even easier like this. But try to compare them in like next to each other rather than up and down, because it's easier to see. Pie charts doesn't matter, right? You're not comparing the heights of anything. But line graphs and bar charts, you should try and put them next to each other rather than above and below. All right, I think that's enough of that. Question 3. Describe some important characteristics that readable tables and graphs have. Readable tables and graphs are, and this is not all of them, by the way, clearly labeled. What do I want to say here? Use visual differences to highlight functional differences. Different fonts, data, etc. Labeled axes. Can't have a clear graph without saying what the units are on your axes. Anything else I want to say there? Not really. I think that's about it. As long as you're labeling your graphs and making sure that everything's obvious about what the graph is. I think when I say label, I mean titled. Titled. Are have labeled axes. There we go. Use visual. Okay. Labeled axes. Yeah, I'll leave it there. I think that's enough. Oops, that's not what I meant to do with this. Make your favorite word processing program. Oh, table. The word in is missing there. Make a table in your favorite word processing program showing frequency, relative frequency, cumulative relative frequency of the following data. These were the grades from my Math 210 summer 2019 Math 210 class. All right, so we're going to need to count these things up. All right, so let's do this. We will go here, we'll make a table. So the way we do that is we go to insert table, and now we have to think. So I'm going to need a header, A, B, C, D, D, F, and a total row. So I need 7 rows. And then I'm going to want a row for the grades and then the 4 frequency things. So I need to make 7 rows by 5 columns. So if I do that, 7 rows by 5 columns, there we go. That's what I want. And so this one's going to be grades, frequency, relative frequency, cumulative frequency, relative frequency. All right, let's try and use good design principles here. I'm going to go ahead and grab all these guys. Let's get the, I want to do the middle here. What am I trying to say? Table properties, that's where I'm going to. I would like to distribute them, not to the top, but to the middle. We'll go ahead and make this bold, italicized, and I want to blow it up a little bit, maybe just a little bit. I like blue, so I'm going to make like an electric blue, not electric, but just very bold blue. And then we're going to go ahead and center those as well. All right, try and make this look a little bit pretty. That's not the greatest, but good enough. A, B, C, D, F total. All right, and so I'm going to go ahead and center all of these. Let's center all this. Hello, that one. Okay. And I want all these things that aren't grade counts to look different. So what I'm going to do is I'm going to bold and italicize those and make them the same blue color, but I'm not going to make them as big, right? So now the headers look different than these guys, And by the way, if you want to, you can do this. If you pick that, if you pick this thing right here, you can choose like that. I'm going to make a bold bar there. Whoop, it didn't bold it. Oh, shoot. I had it a second ago. Yeah, that one. No, the whole thing. Gosh darn it. I want to right click. There's a way to make that border look better. I'll let you poke around and find it. I thought that was it. I thought it was right click on it, but apparently not. Anyway, let's go count up these grades. So A's, how many A's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 A's. No, that one, 14. Okay. And then we've got B's, 1. There were not very many B's in this class. 1, 2, 3, 4, 5, 6 B's. Oop, gosh darn it. C's, 1, 2, 3, 4, 5. Yeah, this class was full of A's and F's. D's, there were like almost no D's. 1. This is almost always the case. Very, very few people end up getting D's. Usually people who are doing bad like give up and leave and end up with an F, which is not great. You can come back from a bad grade pretty well, to be honest. And then F's, there were a lot of those. 1, 2, 3, 4, 5, 6. Oh, not nearly as many as I remember. That is good to hear. 6. Okay, 6 of those. So apparently we have 20, 31, 32 people. 32 people receiving grades. Okay, so now what we're going to do is we're just going to calculate 14 out of 32 and 6 out of 32 and 5 out of 32, etc. I'm just going to do that a bunch of times. I can do the cumulative frequency right now, right? So there's 14. There we go. 20, 25, 26, 32, and 32, of course. So yeah, I'm just going to do the cumulative frequency or relative frequencies, and I'll show you a little trick in just a second here. So I'm just going to grab a calculator here, grab my phone, do it on there. Hello? Phone? There we go. Sorry, I don't have video editing software and could cut this out, but there we go. 0.4375, 4375. 6 out of 32. Oops. Oh my gosh. 6 out of 32. Good Lord. 0.1875. 5 out of 32. 0.1565. That's fine. We'll go 5 decimal places. It's a little excessive maybe, but it's fine. 1 out of 32. 0.03125. And then 6 was 0.1875. All right. Of course, total is going to be 1. Okay. So I'm going to show you a little trick here. I might do a whiteboard on this guy. So 0.4375. And then this guy, so this is going to be, if you want, so here's a little trick for doing quick addition in your head. You can just do this on the calculator if you want, but 43 plus 18 is 61. And this is going to be 1.5%. So this is 62.5%. 65. And then this is another 15.625%. So 15 and 62 is 77. Then I've got another 1.125, so 78.25. 0.78. Did I do that right? I probably did that wrong. 77. All right. Well, apparently it's too early in the morning for me to be doing this. Let's try this again. 0.65. 0.65 plus 0.1565. 78125. Oh, I did do it right. Good. Okay. Fantastic. It is too early in the morning. 0.8125. There we go. And then this guy is, of course, going to be 1. I want to show you a little trick for subtracting from 1, though. Like, let's say I wanted to know what percentage of my students had D's or less, right? So, and I didn't have this column. Like, let's say I want to know what percentage of my students had D's or less. So that's all these, and I could add them all up, or I could subtract the complement of that, right? I could subtract all the people who had F's from 1. So let me show you a quick way to subtract from 1. So I want to do 0.1875, or 1 minus 0.1875. So if I do that, so 1 minus 0.1875. All right, so if I line that up, 0.1875 minus, and I subtract. Now, you could look at this, and you could certainly do this by normal subtraction, right? I'm just going to borrow a bunch of times. But that's the thing. You have to borrow and borrow and borrow and borrow and borrow, and it's a little annoying. So what ends up happening is the thing at the bottom here totals up to 9, makes the total 9, 9, 9, and 10. And I'll show you what I mean by that. These things, 0.1875, it has to add up. I'm not saying this very well, sorry. It's going to come out like this. So this is going to be 0. And then what I'm going to do is say, what do I need to add to 1 to get 9? 8. What do I need to add to 8 to get 9? 1. How about 7? 2. And then this last one's going to be a 10. And if you do that on your calculator, that's what you'll get, 0.18 or 0.8125. And of course, that's what we saw on the chart too, right? 0.8125 is right there. But that's a quick way to subtract from 1. And that turns out to be really useful because of the complement rule specifically, right? When you're trying to figure out everything that's not in a certain category, what you're going to end up doing is subtracting the percentage in that category from 1 or from 100%. And so subtracting from 1 turns out to be actually a relatively handy skill to have in statistics, as weird as that sounds. So anyway, that is my chart for number 4, and I believe I did the other ones too, right? I did 10 and 11, made all the graphs, answered the questions. Yes, you could probably do a little bit more than I did here, right? You could think through this stuff a little bit more, but this looks pretty good to me. I really just want to make you think about how to interpret data and how to, like, some ideas to make good graphs, and then apply that by making a nice table. Okay, I think I'm going to go ahead and end the video there. Yeah, and I will see you in the next